In an era where science continues to reshape our understanding of the cosmos, one of the world's most distinguished physicists has stepped forward with a revelation that could shake the very foundation of modern cosmology. Dr. Michio Kaku, an acclaimed physicist of Japanese-American descent and a leading expert in both classical and quantum physics, has broken his silence about a discovery so monumental that it challenges everything we thought we knew about the origins of the universe. His words are not those of speculation. They are grounded in awe and scientific insight. According to Kaku, the James Webb Space Telescope has made a discovery that defies logic, overturns long-held assumptions, and pushes the boundaries of our understanding. 6 massive galaxies, far larger and older than previously imaginable, have been observed existing mere hundreds of millions of years after the Big Bang. Scientists across the globe are stunned. These galaxies were not supposed to exist. Not this early, not with such size and complexity. To grasp the full magnitude of this finding, consider what traditional cosmology has taught us. The Big Bang theory, first proposed in 1927, suggests the universe began as a singularity, a hot, dense point that rapidly expanded and cooled. For decades, physicists believed that it took hundreds of millions of years for the universe to cool enough to form stars, and even longer for galaxies to develop. But the galaxies captured by the Webb telescope are rewriting that timeline. They are large, luminous, and contain more stars than our own Milky Way, despite forming just 200 to 700 million years after the Big Bang. Kaku's enthusiasm is infectious. Unlike some of his more conservative peers, who prefer to adhere strictly to established models, he embraces the unknown. He reminds us that science is not static, it evolves with evidence. In his words, there are many examples of old and false theories that stubbornly persist because of the prestige of some scientists. Many of these theories were only discredited when a crucial experiment revealed their falsity. He believes this moment is one of those times, where data forces a reckoning with old ideas. The discovery of these universe-breaker galaxies, as some astronomers have dubbed them, has sent shockwaves through the scientific community. If these galaxies are confirmed, it means either the universe is much older than we thought, or complex galactic structures formed much sooner than anyone ever believed possible. Either way, something doesn't add up. The Big Bang model suggests the early cosmos was chaotic and unstable, a cosmic soup of particles and energy. According to prevailing theories, it should have taken eons before matter coalesced into stars, then galaxies. Yet here we are, staring at impossibilities. The implications are profound. Some galaxies observed by Webb appear to be forming hundreds of new stars per year, an astonishing rate compared to the Milky Way, which forms stars only sporadically. Their size and brightness suggest not just early formation, but rapid evolution. How could such organized and massive systems have developed in such a short cosmic window? Kaku is not alone in his amazement, but he stands out for his willingness to speak openly about the consequences. He acknowledges that the Big Bang theory, though supported by decades of evidence such as cosmic background radiation and Hubble's law, is still a theory, and like all scientific theories, it must evolve or fall when faced with contradictory data. He cautions against dogma in science, urging fellow researchers to remain open to new paradigms. Consider this: for centuries, people believed Earth was the center of the universe. They had evidence. 2. The sun appeared to rise and set. The stars moved predictably. It wasn't until better tools and observations emerged that the true heliocentric model was accepted. We could be at the threshold of another such transformation. The James Webb Space Telescope might be our Copernican moment for the Big Bang theory. At the heart of this transformation is Redshift, the Doppler effect applied to light. When galaxies move away from us, their light stretches toward the red end of the spectrum. This redshift allows scientists to estimate how far and how fast celestial bodies are moving. But Kaku and others now caution that even small errors in redshift measurements can yield vast discrepancies in our understanding of time and space. Could some of these anomalies be due to redshift misinterpretation? Or are they signs of an even deeper truth? The answer isn't simple. Some scientists argue that the measurements must be flawed, that the galaxies are closer than they appear. Others, like Kaku, believe the findings are valid and revolutionary. He proposes we consider whether our model of the universe is fundamentally incomplete. Is the universe older than 13.8 billion years? Did the laws of physics operate differently in the early universe? Could there be forces or particles we haven't yet discovered? While these questions may sound radical, they are precisely the kind of inquiries that drive science forward. Kaku emphasizes that we should not fear the unknown. Instead, we should embrace it as the engine of progress. The fundamental work in any science, he says, rests within the experimentalists who keep the theorists honest. The data from Webb is experimental, it's real, visual, observable. And if it clashes with theory, it's the theory that must be reconsidered. It is no exaggeration to say that this moment could represent a turning point in astrophysics. Already, debates are erupting in journals, conferences, and labs around the world. Are we seeing evidence that the universe formed differently than we imagined? Or that our understanding of cosmic time is flawed? Might there be pre-Big Bang phenomena we've overlooked entirely? Meanwhile, Michio Kaku remains at the forefront, urging dialogue and deeper investigation. He believes these discoveries mark the beginning of a new era in physics. We know so little, he admits, about the true beginnings of the cosmos. Yet what we do know, thanks to the Webb telescope, is that the universe is far more dynamic, complex, and mysterious than we had imagined. Kaku also reminds us of the humility required in science. Ideas once held as absolute, like fixed stars or eternal heavens, have all been overturned. Today, we know that planets orbit stars, stars drift through galaxies, and galaxies themselves rush through space at unimaginable speeds. Nothing is still, nothing is settled, and the universe, it seems, still has many secrets to reveal. This discovery does not mark the end of the Big Bang theory, but it does demand a reckoning. Scientists must revisit their models, reevaluate assumptions, and refine their tools. It may lead to a modified theory of cosmic inflation, or even a replacement paradigm altogether. What matters is that we follow the evidence. As we stand on the brink of this scientific revolution, we are reminded that the universe is not only more magnificent than we thought, it is more magnificent than we can think. And with minds like Michio Kaku leading the way, our understanding will continue to expand with the cosmos itself. Thank you for watching. If this exploration of the universe fascinated you, hit that like button, share this video with others who love science, and subscribe for more deep dives into the mysteries of space and time. Let's keep questioning, keep exploring, and keep looking up because the universe is speaking. Are we ready to listen,